All right, we're going to try to do the law of sines today. First thing we're going to do is we're going to prove the law of sines. So what I'm going to be given in the law of sines, the given values are going to be angle A, side A, side B, and angle B. First thing I'm going to do is I know H is going to meet that side at right angles. So I'm going to set up two sine functions. I'm going to say that the sine of angle B is H over A. The sine of angle A is H over B. Now, I'm going to use the same transitive property of equality because when I multiply by A, I'm going to have A sine of B equals H. And when I multiply this equation, I'm going to have B sine of A equals H. Then what I'm going to do is I'm going to set those equal. I'm going to set A sine of B equal to B sinus A. And then I'm going to divide both sides by AB. Because I know that those A's will cancel, those B's will cancel, those B's will cancel. I'm going to have that the sine of A over A equals the sine of B over B. And then likewise, I can set that the sine of C over C if I was given side C and angle C. So in the first example, I have A equals 30 degrees, B equals 70 degrees, and A equals 8 inches. So the first thing I'm going to do is I'm going to draw that triangle. If A equals 30 degrees, B equals 70 degrees, and little a, or side A, equals 8 inches. Now, understand that these are non-right triangles, so that's why I'm going to use the law of sines instead of right triangle trig or SOHCAHTOA. So I'm going to set up the proportion for A, or the fraction for A, the sine of 30 over 8. Equals the sine of 70 over little b. So I'm going to cross multiply. So essentially what I'm trying to solve for is this little b first. I'm going to have b sine of 30 by taking b sine of 30 equals 8 sine of 70. Now, I'm going to divide by the sine of 30 to isolate that little b. Sorry, 8 sine of 70 over the sine of 30. Now that's going to give me a decimal for little b. Now, when I quickly find my calculator, now, to do this, make sure your calculator is in degree mode. You have to switch it to degree mode. So when I type in 8 sine of 70 over the sine of 30, I'm going to get about 15.03. So I know that little b is going to be 15.03 inches. Understand that that is going, since angle B is larger than angle A, side B should be larger than side A. Now, next thing I know is that there is 180 degrees in a triangle. So if I take 180 degrees, subtract 70, subtract 30, that's going to give me 80 degrees. So since I now know that angle, what I can do is I can use the law of sines to solve for little c. So I'm going to set up the original law of sines. Understand I'm going to use angle A and side A instead of angle B and side B because I don't want to use a rounded figure to get another rounded figure. So I'm going to set up that the sine of the sine of 30 over 8 equals the sine of 80 over c. So I'm going to have c sine of 30 equals 8 sine of 80. I'm going to divide by the sine of 30. So I have c equals 8 sine of 80 over the sine of 30. So when I take 8 sine of 80 over the sine of 30, it's going to give me a decimal of 15.76. And that is inches. Notice that the smallest side is across from the smallest angle, the middle side is across from the middle angle, the largest side is across from the largest angle. Next, now understand that I have c equals 82 degrees, b equals 34 degrees, and little a equals 5.6 inches. The next thing I'm going to do is the first thing I'm going to do is I'm going to draw it out. I'm going to call this angle A. Angle B is 34. Angle C is 82. Next thing I'm going to do is I'm going to label A as 5.6. Now, understand that I don't have that angle in its corresponding side, but I know that there's 180 degrees in a triangle. So I'm going to take 180 minus 34 minus 82 and get 64 degrees. Now, since now I have A, I can set the sine of A over 5.6. I can solve for either angle first. I'm going to solve smallest to largest because that comes in effect when I do the law of cosines. So I'm going to set the sine of A, which is 64, over 5.6 equal the sine of 34 over little b. I'm going to cross multiply, say b sine of 64 equals 5.6 sine of 34. And then I'm going to divide by the sine of 64. So I have b equals 5.6 sine of 34 over the sine of 64. Decimal approximation for that, when I type that in, 5 sine of 34. Make sure to close your parentheses over the sine of 64. It's going to be 3.11. inches. Then the next thing I'm going to do is I'm going to set up for another law of sines for little c. So I'm going to say that the sine of 64 over 5.6 equals the sine of 82 over little c. Cross multiply, c sine of 64 equals 5.6 sine of 82. I'm going to divide by the sine of 64. So when I take 5.6 sine of 82 over the sine of 64, it's going to give me 6.17. inches. I just realized in this original problem I only did 5 sine of 34, so I'm going to go back and type in that extra 0.6. That should make that 3.48 inches instead. The next thing we're going to do is a story problem. So I have this angle A equals 26 degrees. S equals 22. Remember, S is the arc length, so that is the arc from B to D. And R equals 20. That is the radius. Now, when I set that up, first thing I'm going to do is I'm going to solve for X. Then I'm going to solve for Y. So the first thing I'm going to do is I'm going to have to get this angle because the only angle I'm given is 26. Now, since I do not have Y or X, I do not know their relationship, what I have to do is I have to solve for this angle C. Now, remember when we talked about radians, we said that theta equals S over R. So this is going to be the angle that it cuts off in radians is the arc length over the radius. So I know that that is going to be in radians 22 over 20. Next thing I'm going to do is I'm going to change that into degrees by multiplying by pi, or 180 over pi. I'm going to take my calculator, and I'm going to take 22 times 180 over 20 pi. And I'm going to get a decimal for this and store it. That should be about 63.03 degrees. I'm going to store that exact value in my calculator as A. Actually, I'm going to store it as C because that's the variable. The next thing I'm going to do is I'm going to set up the law of sines. I'm going to say that the sine of C, which I do have a value for that because I do know this angle, over Y, equals the sine of 26 over 20. I'm going to cross multiply, so I have Y sine of 26 equals 20 sine of C. Then I'm going to divide by the sine of 26. So I have Y equals 20 sine of C, which is that stored value, over the sine of 26 degrees. So when I type that in, it is going to give me 40.66. Next thing I'm going to do is I'm going to solve for X. What I'm going to do is I'm going to introduce a new variable Z. I'm going to say that the sine of 26 over 20 is going to equal the sine of D. Now, in order to get D, angle D, I'm going to take 180 degrees in a total triangle, subtract the 26, and subtract whatever I got for C. So 180 minus 26 minus that stored value, what I have for C. That's going to give me an angle of 90.97 degrees, and that is D. But what I'm going to do is I'm going to store that as D, so I do not have to use a rounded figure. And that is going to be over side Z. I am going to cross multiply. I have Z sine of 26 equals 20 sine of D. Then I'm going to divide by the sine of 26 to solve for Z. So 20 sine of D over the sine of 26. 20 sine of D over the sine of 26. It's going to give you 45.61 or 62. But then I'm going to subtract 20 because I was asked to solve for x. I know r was 20, so z equals x plus 20, so that means x equals z minus 20. That's going to give me 25.62. So here's the next problem. It says a person standing on the street looks up to the top of the building and finds that the angle of elevation is 38 degrees. Then she walks 1 block further, which is 440 feet, and finds that the angle of elevation to the top of the building is 28 degrees. How far is she away from the building when she makes her second observation? Her first angle of elevation was 38 degrees, and then it's going to change to 28. This is her first observation. (38, 28). Now, when we did this looks kind of like a helicopter or a roller coaster problem. But what I'm going to do is I'm going to solve it a different way. First thing I'm going to do is I know that this is a right angle. I know this is going to form a line. So there's 180 degrees in a line. So what I'm going to take is 180 minus 38 and get 142. So I know this is 142 right here. The next thing I'm going to do is I'm going to solve for this angle, 180 degrees, in this triangle right here. So I'm going to take 180 minus 120 or 142 minus 28 to get 10 degrees. That's this angle right there. So what I'm going to do is I am going to set up a law of sines in this triangle, and I'm going to solve for this line z. Why I'm going to solve for that line z is because I want to be able to use that z to find x. So the first thing I'm going to do is I'm going to set up a law of sines. I'm going to say the sine of 10 degrees over 40 equals the sine of 28 over z. I'm going to cross multiply. I have z sine of 110 equals 440 sine of 28. Then I'm going to solve for z by dividing by the sine of 110. So I have 440 sine of 28 over sine of 110. That's going to give me z. It's going to give me 219.82, or yeah. So I'm going to store that as z. So z equals 219.82, but I am going to use the exact value on my calculator. Now, once I find that, I'm going to be solving for x. Because it says, how far is she away from the building when she makes her second observation? So in order to find that, I'm going to find x and add 440 to find out when she makes her second observation, which is the further one. So when I solve that, I'm going to use this. Now I have a right triangle. I can use right triangle trig, so I can use SOHCAHTOA. So to solve for x, I'm going to set up the cosine of 38. So I know that the cosine of 38 degrees is going to equal x over z. This is going to be that stored value right here, but remember I used the store function in the calculator to get an exact value. So when I do that times the cosine of 38, that's going to give me 173.22. So when I take 173.22 and add 440, that is going to be 613.22. feet. This is going to be the same problem we had when we drew the helicopter on fire for chapter 3, section 4. We did this on a worksheet. So when I draw that out, it says a helicopter is having mechanical issues and is forced to land. What I'm going to do is I know that this is 22 or 25 miles. The bearing from the first one is a north 13 degrees east. So north 13 degrees east. I drew that backwards. So I'm going to try that again. So north 13 degrees east, 25 miles apart. This one is 20 or 19 degrees. Now, what I'm going to do next is I'm going to set up a law of sines. I know that this angle is going to be 180 degrees minus 13 minus 19. That's going to be 148. What I'm going to do is I'm going to solve for x, because once I solve for x, I can use right triangle trig to solve for this, but I will do that in a little bit. So the first thing I'm going to do is I'm going to set up a law of sines. I'm going to say that the sine of 19 over x is going to equal the sine of 148 over 25. When I multiply and solve for x, I'm going to have 25 sine of 19 equals x sine of 148. Sorry, just 19. Then I'm going to divide by the sine of 148. So I have 25 sine of 19 over the sine of 148. That's going to equal x. So when I do that, 25 sine of 19 over the sine of 148, it's going to give me 15.35 or 15.36. That is miles. I am going to store that as A. Now, the next thing I'm going to do is I can pick either one of these angles and use right triangle trig. I'm actually going to use 13 because I did solve for x. So now I'm just going to set up a simple sine function. The sine of 13 over y, or sorry, sine of 13 equals y over x. I know x is that 15.36, so I'm going to have x sine of 13. In my calculator, I stored that as a, so then I'm just going to multiply by the sine of 13 to get the 3.46 that we solved for earlier. That is a mile. So a little bit easier than setting up those two tangent functions. Works just the same now that we know the law of sines. So again, this is the same problem that we solved for with my nephews in the problem and Steel Vengeance. Remember, the closer you get to an object, the higher your angle of elevation. So when I draw that, I'm solving for the height. So Blaine is going to be closer to the coaster with an angle of elevation of 48.72. And Braxton is going to have a 42.34. Now, what I'm going to do is they are 45 feet apart. What I'm going to do is I'm going to solve for x. Just like that problem before, what I'm going to do is I'm going to take their 180 degrees in a straight angle. So I'm going to take 180 minus 48.72. I'm going to have 131.28. Then I'm going to solve for this angle. I want to solve for this angle so I can use the law of sines to solve for y. And then I'm going to use right triangle trig to solve for x with this small triangle. To find that angle, I'm going to take 180 degrees in every triangle, minus 131.28 minus 42.34, get 6.38. Next thing I'm going to do is I'm going to take the sine of 6.38 over 45. Equal the sine of 42.34 over y. I'm going to solve for y. I'm going to have y sine of 6.38 over 45 sine of 42.34. So I'm going to divide by that. I'm going to have 45 sine of 42.34. Close that parenthesis, divide by the sine of 6.38. That's going to give me 272.75. I'm going to use that right here. I am going to store that. I'm going to set up, the next thing I'm going to do is I'm going to set up a right triangle trig. This is going to be a sine function because the sine of 48.72 equals x over y. Then when I multiply, I'm going to have y sine of 48.72 equals x. So I'm going to have y, that 272.75, times the sine of 48.72, and I should get the 204.97 feet that I got before.